Cars are getting more complicated every year. This Tundra doesn't have just one cooling system. It has 3 complete separate coolant circuits. It's got engine coolant, inverter coolant, and a dedicated charge air cooler system for the twin turbos. We've got electric water pumps, multiple reservoirs, special coolant, and bleeding procedures. I've been working on these Toyotas for decades, and I can tell you this platform is a completely different animal. It's not just cooling an engine anymore. It's protecting high voltage electronics, a high horsepower engine, and turbocharged systems that depend on precise thermal management to survive. I'll show you where each system lives, how it operates, and exactly how to service all 3 correctly without making an expensive mistake. Before we get started on this job, let's talk about a couple of things. First, you can see next to me I've got some of this Zerex Toyota Lexus Scion coolant. This is equivalent to Toyota's super long life coolant, the pink stuff. And it's important we're using the right coolant on there. We want to make sure it's silicate free and borate free. This is what a lot of the companies are calling their hybrid organic acid technology. It's designed to reduce corrosion in the cooling system with all these aluminum parts. We've got aluminum cylinder heads, aluminum engine blocks, aluminum radiators, and heat transfer devices. We just want to make sure we've got the right coolant in there so we don't have any premature degradation of the cooling system. We don't want to do any damage to any of that. So make sure you grab some of the right stuff. I've got about 5 gallons of this here ready for this job. Between the 3 cooling systems, we should be somewhere close to that, although we probably won't hit the full fill capacity. There will be some left inside the systems in there, I'm sure. But the systems are calling for about 13 quarts on the engine side. I believe it's about 4.5 quarts or so on the intercooler side. And then we've got another 2.2 quarts or so on the hybrid side. So 3 different cooling systems. That's all going to add up to somewhere, just under 5 gallons of coolant. Let's make sure we have enough to do all 3 of these systems. Let's also talk about safety here. When we're working with cooling systems, they are pressurized. And it's important to understand that, especially when they're hot, because if you try to open the cooling system while it's hot and it's under pressure, that coolant's going to blow out all over you. Probably send you to the emergency room with some serious burns. So we want to make sure that this system is completely cooled down before you work on it. Let's not work on a hot engine at all. Not to mention it's uncomfortable working on there with hot coolant dripping down your armpits and things. So let's not work on that. Let it cool down all the way. And then let's just be cautious when we open these radiator caps. So like I said, they're pressurized. These caps are sitting somewhere between 15 and 16 PSI. And while we're here, let's mention the purpose of pressurized systems. And what they're designed to do really is to raise the boiling point of the fluid. So every time we raise the pressure in the system, we also raise the boiling point. Water normally boils at 212 degrees Fahrenheit. Water and coolant may be a little bit higher, especially while it's under pressure. We could see it go up to 240, 250, 260 degrees sometimes before it starts to boil. So just important you understand that. And then when you do take these caps off, we got 3 of them, we want to make sure we're pulling them off pretty slowly. Let's crack them open a little bit, let any pressure out that might be in there before we spin it off all the way. I've removed a couple of the covers off the engine. I've got one here in front of the top of the radiator. I've removed the engine cover off here so you can see the intercooler on there. I want to talk a little bit about these systems, where some of the components are before we get started also. So right here we've got a dual reservoir. We've got this side here is for the inverter coolant, and then we've got the larger side over here is for the engine system. So the engine's got the largest cooling system in there. It's also got the largest reservoir. Don't be fooled, they're attached to each other, but they're separated in the middle. So the 2 separate cooling systems, they just happen to be located next to each other. And then the third reservoir we've got here is for the inverter. Now the inverter is sitting right here and the reservoir is sitting next to it. So it's pretty easy to see. You can locate the inverter here with these bright orange wire loom covers on there, and those to indicate that that's high voltage in there. We don't want to touch that. Don't access anything in there. Don't mess around with it. There's no reason for you to be sticking your fingers in there anywhere. Everything is covered up and sealed. So there's nothing that's going to be dangerous to you here just trying to touch something, but don't mess with that at all. Let's not take anything apart if you don't know what you're doing with the inverter. There is some high voltage there from the DC battery that you have to be careful of. And then of course, the purpose of the inverter is to convert that DC battery power into alternating current. And the electric motor and generator runs on alternating current. It also generates an alternating current when it's being used as a generator to recharge the battery. So it's important to know that we've got that inverter here for that reason. We're converting the direct current to alternating current, and then alternating current back to direct current. And we have to do that in order to allow this DC storage device to work properly. And that's the battery in the back. This inverter will get hot, obviously, and that's why it's got a cooling system on it. We want to make sure those electronics stay cool and that everything is working the way it's supposed to. It does have its own water pump as well. There's a little electric water pump that's sitting back here behind the coolant reservoir. And that's important to know because when we bleed this system, we want to know what kind of sound that pump is making. We want to make sure there's no cavitation in there. There's no air in that cooling system at all. We want to be able to listen to that pump, maybe put your hand on it and feel it even, just to make sure that it's running smoothly the way it's supposed to be. Let's talk about the turbo system on here and the intercooler for that. Now, traditional intercoolers are air-to-air intercoolers. They're just running the air across these small radiators, the intercoolers, in order to try to cool the intake charge that's already been compressed by the turbos. This system works a little bit differently. We've got on here an air-to-water intercooler, or air-to-coolant, we should call it. And it works pretty much the same. The only difference is we've got coolant cooling off the air charge instead of we've got air cooling the air charge. So maybe a little bit more efficient, especially where this is located. It's not easy to get air up to the top of the engine. So what this system does, we've got our reservoir here. We've got our intercooler over here with a couple of pipes to it. Okay, and we've got an electric water pump that sits all the way down here, just below the right side headlight, passenger side headlight. So that's where the other electric pump is for the intercooler system. And then of course we've got two heat exchangers in the front, one on either side. They look like small radiators, a little bit thicker than a normal radiator, but much smaller. So one on either side and a bunch of coolant hoses to connect everything. So the water will circulate via that electric pump up into the intercooler. It'll remove some heat from the air charge that's in there, and it'll bring it back through the reservoir down into the top of the heat exchangers down there, little radiators. And then that coolant will flow back through the water pump back into the system again. So it's just constantly circulating in there, getting hot at the intercooler and then getting cool at those heat exchangers at the end of that run there. And that's how this system is designed to work. And that electric water pump is another one. We want to know where it's at, and we want to be able to maybe put our hand on it or at least listen to it, see how it sounds, make sure there's no air cavitation inside that pump after we're done servicing the system. As far as the engine goes, I told you we've got a reservoir here for the main engine coolant, and that's going to work like a normal system does. It has a mechanical water pump at the front of the engine, and that water pump circulating the coolant through a thermostat, through the heater core, through a bunch of stuff like a normal cooling system does. So nothing different there as far as what you're used to on a normal car. Just important to know that these three systems are completely separate, and we've also got, in addition to that mechanical water pump on the engine side, we've got two small electric water pumps for the inverter and for the intercooler system. In front of this radiator here, this is the top of the radiator. In front of that, we have another radiator, and that's for the inverter system back here. So you can follow these hoses here coming down from the inverter, and they go up and across and into this smaller radiator we have for the inverter. And then of course we talked about those other heat exchangers that are down in the grill down there below the headlights, one on either side. So you should be able to locate all the parts in here. I can tell you that we're going to locate all these Petcocks on here, but as long as we're here for geographical positioning here, you've got straight down here where this intake duct is where the Petcock is for the inverter system on here. Okay, at the bottom of this radiator, the big radiator for the engine, there's also a Petcock with a little yellow fitting on it. Okay, that's going to be for the radiator drain. And behind the radiator, there's also an engine block. I'm going to show you guys how to drain this from the engine block as well. And that's going to be sitting up just right next to the water pump almost. Behind the fan blade over there, you'll be able to find it. It's really difficult to see. I'm going to try to get close in for you and show you what that looks like. And then of course we've got the third system on here, has a drain Petcock on it, and that's going to be in one of the hoses that connects the two heat exchangers at the bottom. That's going to be just forward of the radiator support in the lower portion of the grill down there. Now this truck has got a custom lower bumper on it on there, so there's some metal bracketry in the way, but we'll get you a good close-up of where that's located. Your truck might look a little bit different. If you've got the stock bumper on there, it might actually be a little bit easier to access for you. So you guys can see what's going on. I want to go ahead and remove this air box on the passenger side. I want to be able to show you clearly what this Petcock looks like for the hybrid inverter. So you can see I'm in here past this reservoir, and I'm looking down the side of the engine here, and I want to get in close for you. That's why we took this air box out, so I can show you this hose assembly. It's got this Petcock on it, okay? And then we're going to go ahead and loosen this right now. There you go, cracked it loose. And we're going to put a hose on this little nipple. And then we'll run this hose out the bottom of the fender. This way we can drain this out the side without spilling all over the truck. So that's what we're going to get to for this hybrid inverter system. Okay, this is the petcock. It's right down near here. Just follow the hose down and you can see it right here. Okay, now there's some room here in the fender liner underneath the fender where you can get the hose out the side, and hopefully we'll drain this into a bucket without making a mess. For the sake of efficiency, we're going to try to service all three of these cooling systems at the same time. So what I want to do is start off, I'm going to slowly open these caps up. You can release it, make sure there's no pressure in there, and then remove it slowly. And we talked about these being pressurized systems. If you look at these caps, this one says 108 kPa. That's a kilopascal, and that's equivalent to somewhere between 15.5 and 16 psi, which most systems nowadays are at least 15 psi. Some of the older cars, you might have seen them a little bit lower, but that's pretty standard for our world right now. Let's go ahead and take all three of these caps off. We'll set them to the side. Now this truck's been sitting for a while, but you can still hear, or maybe you couldn't hear, there's a little bit of pressure still in that engine side. And we're going to separate these three, put the caps back where they came from. They look all identical, but why mix them up? We've got the engine cap here, we've got the intercooler cap here, the inverter cap over here. Now we need to get under the truck and I'll show you where some things are. Okay, so I brought this truck up in the air a little because I want to show you that you can also access this from the right front wheel well. So what I've done here, this is kind of tricky to record, and that's why I'm going up in here. But I want to show you here that right up in here is where we've got that petcock. Okay, so you can put a small hose on here. There's about an 8mm diameter of the internal of the hose. You can see this one. And then I put a bucket here. I'm just sitting on the sway bar just to try to collect this fluid so we're not making a mess. Now keep in mind, this only holds about 2 quarts of fluid here on this inverter. So I'm going to go ahead and open this petcock right here from this fender. That's why I cracked it open up top. And I just wanted to be able to direct it into a bucket while we're draining it. So I'm slowly spinning this open here from the inside. And then we should be getting some coolant out of here in the bucket. Now, hopefully you can see that. Okay. And then we're just going to let this drain completely. We've got the cap off the system. I may have loosened that a little too much. Spin that in just a little. All right. Let's go ahead and let that drain. We're going to go up in the air and do the other ones at the same time. So we have to access under here the petcock for the radiator. We're going to have to take this TRD cover off on here. If you've watched some of my other videos on this TRD truck, they've done a nice job with this cover actually. It's big and bulky and clumsy, but they've got a couple of hooks in the front. If you just loosen these 2 front bolts on here and give it enough room to wiggle, they will actually hang the cover on these 2 bolts and this one hook that's in the back here. It's actually on this side, on the driver's side. So we can loosen the 2 front ones. Don't take them all the way out. Make sure you've got plenty of threads to hold it, hang in there, and then we can take these 4 rear bolts out. The cover will just kind of hang there and then allow us to manipulate that out. I'll show you how that looks. These are 12mm heads on these bolts. And then what you can do, you kind of lift this up, and then you can just slide this cover to the side and then forward, and then it'll come off in one piece here. Now with that cover off, we have access to the bottom of the radiator here. So there's a yellow petcock that's right over here. That's for the radiator itself, the drain. And then I told you in front of this radiator support here, up in this hole is where we've got the hose that connects the 2 heat exchangers for the intercooler. On the driver's side, there's another petcock here for that. But what we want to do is we're going to put another hose on this one, and then we're going to drain the radiator. We'll do one for the intercoolers over here. Let's see how we're doing with our coolant here for the inverter. It looks like it's just about empty. All right, so I put another hose on here. This is on the petcock for the intercooler. And we're gonna go ahead and open this one up and start to drain some of this. And we're gonna give this some time to drain completely, and then we'll move on to the next one. So just for the heck of it, I've taken everything I've drained out of the inverter here and put it into this little container. I'm gonna pour it into a measuring bucket here so I can see how much we took out of there. You can see it doesn't look like a whole lot. So let's go ahead and see what we've got in this thing. So I can tell you, it looks like roughly 3/4 of a quart, so not anywhere near the 2.2 quarts that the system holds. When we drain that from the petcock where it's supposed to be drained, we're really barely even getting half of that coolant out there. So guys, this is another example of, you know, a manufacturer has recommendations of doing it at 100,000 miles or 150,000 miles, sometimes never. I think it's a good idea to exchange, even if you can only get part of the fluid, I think it's a good idea to exchange at least half of it on a little bit more regular interval than what the manufacturer recommends. You can take that or leave it, however you like it. I'm not here to argue with anybody. I just kind of like to err on the side of caution when it comes to maintenance and trying to get the most longevity out of your vehicle you possibly can with as little expense, at least uncontrollable expense as you can down the road. While we've got that intercooler draining, we're gonna go ahead and open the petcock on the radiator as well. We'll get this one draining, see if we can save some time. So I've got my intercooler here down to a slow drip. It's just about done. And I'm looking at my fluid here, what I've gathered. And I'm just about 2.5 quarts is what I've drained out of this intercooler system. So again, I think the spec on it was about 4.4 quarts. And we've got, you know, maybe just a little more than half of that. So I don't expect to get it all out of there. I'm gonna go ahead and tighten this one up and take the little hose off it. All right, so I've just capped up the petcock for the radiator on the engine side. That's the engine coolant. And I've got as much as I can out of there, and I've got just under 6 quarts out of the radiator alone. Now there is one more step we got to do here, and we're going to drain the block here. And I showed you there was a fitting up here above this lower hose next to the water pump drive pulley. And there's a small spigot on it, and there's a 10mm bolt. We can go ahead and loosen that up and drain the rest of the block as much as we can get out of there. So let's go ahead and do that step now. The same process applies here. We're going to put this long hose on here, so we'll try to avoid getting coolant all over the place. Now this is a tricky fit here. I can't get in here easily. But I'm going to try to get some close-ups for you to show you what it looks like up in here. And you're going to have to feel your way around this thing just a little bit. There's definitely not a lot of room in here to work. I've got my hose on. I went ahead and loosened up my bolt with the 10mm, and now we're going to go ahead and open this thing up and see what we can get out of the engine block. All right, it's been a few minutes here, and as you can see, we've come down to a pretty slow drip here. This is from the block drain on the front of the water pump there. So we're ready to cap this up. We've got a 10mm socket here, and we'll go ahead and tighten up that little petcock that's on there and pull our hose off. Now this thing you can do by hand up until it gets tight, and then just snug it up here once you get it all the way in. It doesn't take a lot of effort, and I wouldn't over tighten it. I think the torque spec on here is pretty darn low. I'm using a 1/4-inch ratchet, and that should be plenty. Pull that hose off there, and let's measure and see what we've got from the engine block. Always curious to see what we're taking out of these things. Said the spec was a little over 13 quarts for the whole system. It looks like about another 3.5 quarts here from that engine block drain. So we'll add that to our 6 or so quarts. We've got just under 10 quarts here we pulled out of this engine. So I figure there's a few more floating around in there somewhere. They're probably not going to get out. Let's go ahead and cap all these up, make sure all our petcocks are tight. We're going to double check all 3 of them, and then we're going to put the cover back on the bottom here, and then we'll get up top and we'll show you how to fill and bleed these things. I'm going to hit these parts here right around the belt with a little bit of brake clean just to make sure I don't have any residue lingering around on the belt or anything before we put these covers on. Get that all cleaned up, give it a quick blow dry. All right, let me show you how to hang this cover with one man here. Don't forget that hook you got over here on the back. And then we're just gonna try to hook that in these front ones at the same time. I'm gonna hold this up here. And then just gonna slide that into place and line up our holes. Now you wanna be extra careful. The back of this can still move around a little bit, so let's get some bolts in there before it falls down. As with anything, you should start these by hand before you use your impact tool on here, or your ratchet even. You want to make sure you caught a few threads all the way around. If you put some cross threads in the frame, cross member here, you're going to have some problems. So with everything cleaned up here, the cover's up tight. Don't over tighten these bolts on here. You don't want to cross thread anything or strip anything on here, so just be extra careful on those 6 bolts. Let's go down and get some coolant in this. All right, so I'm back under the hood now. Got everything tidied up, and we're just going to go ahead and start filling this. I've got this funnel here we use for cooling systems, and it's got a little plug inside. So this allows us, if we're getting too full, I can just stop it right here. I don't have to worry about necessarily how much I put in there, where it's going to overflow or something. So we're going to kind of monitor this level. We know it doesn't take a whole lot of fluid here. So I'm just going to put some in and pull that plug, let a little bit in the system. See how much this thing actually takes. I'm going to fill that up just to the full line. And what we need to do is we need to cycle this pump on here. So anytime this vehicle's in the ready mode, the inverter pump should be running. Now that's not necessarily true for the intercooler water pump, the electric water pump that's driving the intercooler system. So that one will need to get the vehicle running and up to temperature also. So a couple ways we can do that, but I'm going to show you here. There's a few different things that we can do. So I'm going to demonstrate a couple of them here for you. But the first thing I want to do is just get all 3 of these topped up to where they won't accept any more coolant past the full level. And then we're going to go ahead and squeeze a few hoses, and we'll see if we can get that level to move at all on any of these systems. And if not, we're going to go ahead and get this thing in ready mode and see if we can get that electric pump to cycle a few times. Let's do that. Okay, so that's just about at the full level on the intercooler, a little bit past actually. All right, so now we've filled up our coolants here for the hybrid system and for the intercooler. We're going to go ahead and use the airlift system on here. Now, I can tell you the procedure in the manual calls for you to inject coolant into the bottom of the radiator where the petcock valve is, and that's not typically easy to do if you don't have some kind of equipment to do that. If you guys have seen my other videos, you know I like to use these airlift tools that helps evacuate the entire cooling system and then refill it without putting air into the system, which helps us get a pretty close to a full bleed on the system before we ever start the car. So that's what we're going to do here. I've got my tool that just fits inside the top of the reservoir here, and you just want to make sure it has a good seal on it. And then I've got my valve closed here for the coolant. And what I'm going to do, let me bring this where you can see this. I've created a video on how to use this tool already. You can watch that standalone if you want to know how to do this process, but I'm going to walk you through it real quick in here. I'm going to put this thing to the bottom of my full jug here. Let me turn it a little bit so you might be able to see the marks on here. So I like to go all the way down until I feel that little screen hit the bottom. And then I'm going to go ahead and I've got this hose that's connected to this jug turned off. So the valve is 90 degrees to the hose. And then I'm going to turn my air hose on. What it's going to do is going to suck all the air out of this engine cooling system. And I'm just going to pull a vacuum in here down. It's going to get down in this green range somewhere. So let's go ahead and turn it on. It's going to get a little noisy. And let's let this thing do its job removing air from the system. We're going to see the radiator hoses collapse on here as this thing starts to draw a vacuum. This hose is just a hose for the air to come out. So if you have some coolant in the system, it'll probably drain out of there. We'll make sure to put that down in the bottom somewhere where it's not going to make a mess. So I can see my hose is collapsing there now, and my vacuum is starting to hold steady. We're going to leave this on here for a couple of minutes till we get a deep vacuum as far as we can get, and then I'm going to show you how to draw some coolant up in here. As a matter of fact, while this is going, I'm going to purge this hose a little bit. I want to get the air out of here. So I'm going to open that very slowly till I get the air to come all the way up to the valve. If you can watch this hose, I'll go behind so you can see this. See, it's drawing some coolant all the way up to here. I don't want that air pocket to end up in the cooling system after we're done evacuating it. So now I've got coolant in the hose. This is all the way at the bottom of the barrel. We're pulling a nice vacuum here in our system. Looks like about 26 inches of vacuum or so, if that gauge is completely accurate. Sounds about right. And we're just going to go ahead now and shut this valve off. And we're going to draw some coolant in this system. And you can see the coolant level is going down as we're filling. Now if we get close to the bottom, I'm going to have to turn this off and stick another one in there. I don't want to suck any air in the system if I can avoid it. Right there, we're going to switch bottles. Put that right in the bottom of that one and we'll continue. Now we're watching this gauge. When this gauge drops all the way back to 0, that means the system has got no vacuum left in it. It should be full of coolant. Okay, we're just about done right here. Turn this one off. I'm just going to pull this tool back out. I'm going to open this thing up here. And we're done with this. So the first thing I'm going to do, I'm going to have a helper here start this engine up. Actually, just going to put it in ready mode, but because the engine is cold, it's going to stay running. There are some times when you'll put this in ready mode, the engine won't start at all. So if the engine was already warmed up or something, or if you were in a vehicle that had a fully charged battery already and it didn't feel like it needed to start yet. But generally when you're starting a hybrid for the first time when it's cold, it's going to want to run the engine anyway. So if it didn't, I wouldn't be concerned. As long as you're in ready mode, your green light's lit up, it should cycle the inverter pump. So this is the first one we're going to look at here. I want to go ahead and put this thing in ready mode and see if I can hear that inverter pump running. All right, go ahead. So I can already see the inverter pump is starting to circulate, and you can see the bubbles in here. I don't know if you can see from there, right down in here, the bubbles are going and starting to take the coolant down a bit, and that's what we want. So we're going to cycle this, let this run a few 30 seconds or so, we'll shut it off, and then we'll do that again. I can also tell you that my intercooler system needs a little more coolant too. Okay, so we've shut the vehicle off. I'm going to top up the intercooler fluid. And then we're going to get that to the full level. We're going to come back over here to our inverter. I'm going to top this one up to the full level. All right, and then we're going to go ready mode again. Here we go. Do that for another 30 to 60 seconds. Now that we've got our system bled for the inverter, we went and did that ready cycle a few times, 2 or 3 times, till we got all the bubbles out of it. We need to get a little temperature in this thing for the intercooler coolant and also for the engine coolant. So we'll have to get this thing running, and we want the thermostat to open ideally. So the way you'll know the thermostat is open is if the lower radiator hose starts to get warm. Okay, so it'll usually, the upper hose will get hot pretty quickly. The hot coolant comes into the top of the radiator, goes all the way down, gets cooled, and comes out the bottom cool. But if that thermostat doesn't open, it'll never let the bottom fluid out of the radiator back into the engine. So we really want to have the upper and lower hoses both to be hot at some point, or at least the upper hot and the lower warm. It's a good indication that your thermostat's open. And once it's done that, then we know we've got at least the thermostat's open and the block is purged of air, and then we can let this thing cool down again. Ideally, we let it cool all the way down and then double check the fluid in the morning and see if the fluid took a little bit more, if we need to add a little bit more coolant to any of these reservoirs. So There is a process in here to put this into maintenance mode. So this car is not doing any problems here. It's running for us, no problem. It hasn't shut the engine off due to some hybrid operation on us. But sometimes that happens. We see it a lot on the Camrys and things like that. So it might be an opportunity for you to put this in maintenance mode. That'll just keep the engine running for you so that you can complete some tests, or you can keep the car running at 2,000 RPMs. Simple operation for that is really just to turn the key on. You pump the accelerator pedal 1-2 times. You put it in neutral, go 1-2 times on the accelerator to the floor. You put it back in park 1-2 times, and then you start the car up, and it should stay running for you. And then to exit maintenance mode, you'll just turn it off and wait 30 seconds. So if you needed to enter maintenance mode because your engine wouldn't stay running, that's one way you can do that. I don't think we'll need to do that on here. This thing's staying running here for a few minutes, no problem on its own. If it shuts off, maybe we'll put it in maintenance mode. But we definitely want to make sure we purge all the air out of the system. It's really important that we do that. And that's why I recommend we use the airlift system on here. You don't have any way to inject your coolant in the bottom of this radiator. Neither do I even. So using the airlift system is the best way to pull all the air out and let it suck coolant back in under vacuum. So I think we've done a pretty good job. I did have to reduce the level a little bit on my engine reservoir. It was a little bit overfull, so I just brought it down to the full level while we warm this thing up. And then once that thermostat opens, we'll see if it takes a little more coolant. Be careful not to open it hot. And then again, we want to let it sit overnight and see what it looks like in the morning. Give it another heat cycle. So it's always a possibility that you gather an air pocket after the car sits overnight. After it fully cools down, really is what I should say. It doesn't necessarily have to sit overnight. You want to let it fully cool and see if any air develops in the system. We might need to retop the reservoir. So that we should be 95% there after the thermostat opens anyway. All right, so I wanted to show you guys there is an alternate method here to run these electric water pumps in order to bleed the cooling system. If you have a scan tool that's capable of doing that, you're welcome to access the system here. This one has auto VIN scan like most of the better scan tools do. It should automatically pull up your VIN with all your vehicle information. Now, of course, you want to make sure your ignition is on. This way you can communicate through the OBD2 port. And once you're in the system here, we're just going to go ahead and select our area. We've got all our vehicle information in there. We'll select OK. We'll continue through here. And then what we'll need to do is we'll need to select the system on here. So if you're going to run the intercooler water pump, you're going to want to use the ECM side of this. Okay, that's controlled by the engine control module. So we'll go into that. And then you're going to want to go into actuator tests. And in here, we should be able to scroll through and look for the feature. Here it is, control the intercooler water pump. So we want to select that. Select OK. Then you have an option here in this scan tool to monitor the data, the speed of the pump, duty cycle, and those things. So if I wanted to select some monitoring data so I can get a little bit of feedback of what's happening here, I'll go ahead and select monitoring data. It's going to pull me up this list of information on here. And you can select whatever is relevant to you. But what I like to do, if I'm having the option of this feedback in here, I like to go into, let's see if we can scroll a little further here to the intercooler water pump. There's a lot of information in this tool here. So fortunately, this is what we've come to with modern cars. There's just tons, endless stuff in these things. So I'm going to keep going here. So I can find this for you. Should be getting close. Getting closer. All right, here we go. So you can select here intercooler water pump and then intercooler water pump speed. And we can go ahead and display these on the scan tool while we do the test. Now you could supply all this data at the same time. We don't need all that. So on here you can see we've got control the intercooler water pump. We've got the water pump speed. I don't know why it's stuck at 160 RPMs. Maybe that's the low setting for this tool. I'm not sure. And then the intercooler water pump here, the value is 0. So we're going to do our input on it. And let's say we want to run this thing at 50%. We can just type in 50 and hit OK. And then you can see the intercooler water pump speed jumped up to about 3,000 RPM. So we've got it running about 50%. on there, and if you were to go outside and put a stethoscope on that water pump or try to put your hand on it, you'd probably feel some motion. You might see a little motion in the reservoir, and that'll indicate that this water pump is actually circulating for you without having to even start the vehicle up. So this is a nice feature to have if you have access to a scan tool. I'll quickly go through and see if I can show you the other side of this. Let's not go there. I'm sorry. Go back, search. Select that. And I'll show you where we can find the settings here. We're going to go into system selection. You need to get into the hybrid control. So this HC hybrid control is where we can go in order to get into the hybrid system. And that inverter water pump is going to be in there. So we'll go to actuator tests again. And then you can see here, activate. It's at the top setting, activate the inverter water pump. We'll select OK. Again, if you want to do the monitoring data, you can do that. It just helps to get a little bit of feedback. So let me see if we can get all the way to the inverter. There it is. So you have here inverter water pump, pump duty ratio, percentage on to off, and then the water pump revolutions of speed, the RPM. I'll go ahead and select that. And then you can see here to activate the water pump, the value is at nothing right now. It's not on. And then it's telling you the inverter water pump is off. That's the status of the pump. It's also giving you the pump duty ratio. It's saying 5% right now. And then inverter water pump revolutions 160. Again, I don't know why it's displaying that value on here, but let's go ahead and turn it on. Now you can see that inverter water pump jumped up to 5,300 RPMs, and it's also telling you the feedback on here is giving you the water pump is on. Okay, so same process before. You can go out there and watch your coolant circulate a little bit, make sure you have no bubbles in there. But that would be the process with the scan tool. All right, so I want to show you guys on my computer some information on here on how to bleed this system. Now, first we're going to be talking about the engine coolant system on here. So this is mainly for the radiator and engine block coolant. And you can see on my screen here, we've talked about some of the things that are in here, the drain on the water pump and the petcock at the bottom of the radiator. What I really want to get to is the point where we have to add the engine coolant, which you can see over here. And there's a couple of things in the procedure that they want you to do. And you and I, neither one of us have the ability to do this without the tools from the factory. So they want you to remove the radiator drain petcock, remove the O-ring from the radiator drain petcock, and then they want you to inject the specified concentration of coolant through the radiator side until the radiator is full. Now this is the part you're going to have a problem with, trying to push fluid up through the bottom of the radiator. Part of the reason they want you to do that is because they don't want any air in the system. They know there's going to be air in the block, and you're going to have trouble bypassing the thermostat in order to get that block full. And this is why we generally use the airlift style coolant evacuation system. This way we can purge all the air out and then refill it with the tool. So instead of injecting through the bottom, that's how we'll be doing it. And then I also wanted to mention on here that we've got the bleed procedure for the cooling system. So they want you to warm this up once you've got the coolant full in it. Basically after you've injected it in the bottom, or we've sucked it in using the airlift tool. And they want you to have the thermostat open while you've got this running. So you have to let it run long enough for the thermostat to open and circulate the engine coolant for several minutes. And maintain your engine speed at about 2,500 to 3,000 RPMs. Squeeze the radiator hoses a few times. Try to pump some air out if there's any that's collected in there. And then stop the engine, let it cool down. And then you can go ahead and check the level after it's cooled to see if it's at the full line. And then if it's below the full line, you can add to the full line. So just kind of wanted to show you that. And then let's move on to the next one. All right, and for the procedure that I've shown for the inverter cooling system, you can see the petcock here that's on the hose we showed. And then there's a process here to bleed the cooling system when using the GTS. That's Toyota's factory scan tool. And then we're going to go into the powertrain hybrid control active test and then activate the inverter water pump. Now I'm going to demonstrate that for you guys using an aftermarket scan tool. So you'll have that information that I can show you how to walk through that to activate this water pump. There's a procedure here for when not using the Toyota scan tool. You can just turn the ignition switch on to ready, and then turn the ignition switch off after a little bit and add coolant to the full line as prescribed, and the air will be bleeding as each time you cycle the ignition. So I want you to repeat that step a couple times here until you've got all the air out of the system. Okay, so that inverter pump will run with the key in the ready mode. So anytime this thing is in the ready mode, that pump should be running. and that's how you're going to bleed the air from this thing. So it's important we get the air out of that, whether you use the factory scan tool or using a manual bleed procedure here like I'm showing. Now I've pulled up the information for the intercooler coolant. I'm going to let you take a peek at this as well. So went through the procedure already, but I just want to get down to the bleed procedures on here. And what's nice about this diagram like this one, let me click on this, and it gives you a good image of what these heat exchangers look like. These are the radiators for the intercooler, okay? And we've talked about these hoses that are here, and we've got a petcock right here in the middle of that hose that we've showed you already. So it's nice sometimes to see an exploded diagram when all these things are hidden behind covers and underneath headlights and all those types of things. All right, so we're here to add the coolant for the intercooler. And then we've got another procedure here for when using the Toyota scan tool. You can fill the coolant up in the reservoir to the full line. And then here they want you to get into the powertrain, engine, and active test to control the intercooler water pump. Again, I've got a video here included here that I'm going to show you how that operates on an aftermarket scan tool. And when the air is bled out, they want you to add the coolant to the full line in the reservoir tank, install the cap, so that you know already. But then here's the procedure again when not using the Toyota scan tool. So I usually give you a procedure both ways in case you don't have access to this scan equipment. You can go ahead and add coolant in the reservoir like you would normally, and then they want you to start the engine. If you see that step 4 here, they want you to start that engine, and then they want you to run this thing. So in order to operate the electric water pump assembly, they want you to maintain this thing at 2,000 RPM with shift lever in park or neutral, preferably park, for 1 minute, then stop the operation for a minute. And you're going to continue to do that. So repeat that operation a couple more times, and you want to make sure there's no bubbles left in the intercooler reservoir tank, and then the coolant level stabilizes. Okay, so that's basically the procedure, and I just wanted to show that to you guys in case I was a little unclear here in the video how to do that. All right, so the last thing is we let this truck cool all the way down. We want to make sure that the coolant level is actually correct after it's been through this heat cycle and cooled down again. Double check the reservoirs. The only thing we noticed here, the inverter was just a tad low, a few ounces or so, so we just topped that up. Otherwise, everything is good to go here. Now, I hope you guys were able to follow all these steps here. I've given you some solutions to bleed the cooling system without some scan tools or factory equipment, and then also how to use a scan tool. If you have any questions on the scan tool I'm using, you can go ahead and message me, and I'll try to give you some answers on that stuff. I'm probably actually going to create a video on that scan tool. It's fairly useful for an inexpensive price. You don't have to spend thousands to get those functions out of it, so kind of nice there. And of course, it's easier to use the scan tool to bleed these systems, probably because you know the pumps are running, and it's easy to confirm that they're operating, and you know you're doing it the factory way, I guess, so to speak. But the other ways work just fine as well. And hopefully you followed all of that. I appreciate you watching this video. Hopefully it's been helpful for you. Get your cooling system services done on your own truck. And don't forget to like and subscribe to the channel. We've got lots of great content for you. We're trying to produce this information so that you guys can handle some of this maintenance on your own and save yourself some money. So please share with anybody you know needs this information, and follow us in some other videos. We've got plenty more content for you right over here. We'll see you in the next one.